The Storm Prediction Center in Norman, Oklahoma, just flagged a multi-day severe weather outbreak stretching from Dallas to Kansas City. CAPE values are nearing 3,000 joules per kilogram across the southern plains. Wind shear numbers are climbing past 50 knots. And for the first time this spring, all three major forecast models have locked onto the same answer: the same trough, the same dry line, the same deadly moisture return from the Gulf of Mexico. The last time models agreed at this level, the result was the most costly tornado outbreak in American history. That is not a stretch, it is a data point. And right now, the data is pointing straight at Oklahoma, Kansas, and North Texas. How does a forecast go from possible severe weather to historic outbreak confirmed in 72 hours? What are the models actually seeing that has the SPC issuing enhanced risk outlooks with major tornado hatching days before a single storm has fired? And what happened the last 3 times the air loaded up like this across the Central Plains? The answer to that last question is the part that should get your attention. 72 hours ago, the GFS and the European model were telling 2 clearly different stories about this week's weather across the plains. The GFS was more bold, with the upper-level trough digging into the southern Rockies. The Euro was holding the energy further north. The NAM, which runs at finer detail but shorter range, had not even started running this event yet. Forecasters at the SPC were watching, but the signal was messy. The day 4 through 8 outlook carried language about doubt in the details, which is weather forecasters speak for "we see something coming, but the models have not made up their minds." Then the Tuesday morning model runs dropped, and the gap between them vanished. The GFS shifted its trough position southward. The Euro strengthened its surface low. The NAM came online with an answer that split the difference between the 2 globals and added its own fine-scale detail. All 3 models were now painting the same full weather picture across the Central Plains: a deep angled trough over the western United States, a strengthening surface low between 998 and 1,004 millibars, a razor-sharp dry line setting up from western Texas through western Oklahoma and into south-central Kansas, and a river of moisture from the Gulf of Mexico, pushing surface dew points into the upper 60s and low 70s across everything east of that dry line. In severe weather forecasting, this level of agreement is truly rare. The 3 models use different physics packages, different data processing methods, different levels of detail. They are built to disagree with each other on the fine points. When they stop disagreeing, forecasters pay very close attention. The process inside the Storm Prediction Center works like this. Forecasters like Greg Carbon use multiple global models to read the state of the air. They begin to see patterns several days in advance. The models give clues, but it is the agreement of those models that turns a maybe into a likely. What the models are agreeing on right now is not subtle. CAPE, which stands for Convective Available Potential Energy, is the fuel for thunderstorms. A typical afternoon thunderstorm might tap into 500 to 1,000 joules per kilogram of CAPE. A severe thunderstorm making large hail usually needs at least 1,500. For the kind of supercells that make strong to violent tornadoes, forecasters look for values above 2,500. The models are showing CAPE values nearing 3,000 joules per kilogram across the southern plains by Wednesday afternoon. Some runs are pushing past 3,500. Storm relative helicity, which measures the spinning power in the lowest 3 kilometers of the air, is climbing into ranges that match some of the most active tornado settings on record. For context, the Dodge City, Kansas sounding during the May 18, 2025 outbreak measured 571 meters squared per second, squared of helicity, and a significant tornado parameter of 12.9. That reading sat above the 90th percentile of every EF4 and above tornado setting ever recorded in the United States. The models are showing SRH values for Wednesday evening that reach those same ranges across central Oklahoma and south-central Kansas. And the deep layer wind shear, the difference in wind speed and direction between the surface and 30,000 feet, is forecast to top 50 knots across the threat area. That is the engine that turns ordinary thunderstorms into rotating supercells. Supercells are the only storm type that makes major tornadoes. The SPC has already issued an enhanced risk, level 3 of 5, for central Oklahoma through southern Kansas on Wednesday. The tornado chance zone shows 10% with major hatching, which means forecasters believe EF2 or stronger tornadoes are likely within that area. NSSL's machine learning model, which crunches thousands of weather factors at the same time, flagged Wednesday as one of its stronger signals of the spring season. But here is the detail that matters most: the timing. The dryline is expected to sharpen through Wednesday afternoon as surface heating builds across western Oklahoma. Discrete supercells, the separate rotating storms that are most likely to make tornadoes, will fire along that boundary, starting around 4 to 5 p.m. Central Time. Those early storms will have the best chance of staying separate, meaning they will not merge into a messy squall line that weakens the tornado threat. Single storms, each with their own rotating updraft, tracking northeast across central Oklahoma and into southern Kansas. Then the low-level jet kicks in. After sunset, a southerly jet of wind at roughly 3,000 feet will speed up to 40 or 50 knots across the southern plains. This jet is the key piece that separates a bad tornado day from a historic one. It shoves huge amounts of moisture and spin into the base of supercells that are already rotating. The strongest tornadoes in American history have almost always happened during the evening and overnight hours when the low-level jet is at peak strength. Across the threat zone, emergency managers are bracing. In Bartlesville, Oklahoma, Deputy Director Melissa Mayes and her team at Washington County Emergency Management are treating this as the first real event of the season, the one where people finally start paying attention as spring storm season arrives. In Douglas County, Kansas, Deputy Emergency Director John Stepetic is dealing with a different problem. Even lifelong Kansans sometimes get confused about what the outdoor warning sirens actually mean. That confusion will be tested in the coming hours. The threat window runs from late Wednesday afternoon through 1 a.m. Thursday morning. Oklahoma City, with its 1.4 million metro residents, sits inside the enhanced risk zone. So does Norman, home to roughly 125,000 people, and, oddly enough, home to the Storm Prediction Center itself. Tulsa and its 1 million metro area fall within the broader threat. Wichita, with 650,000 people across its metro, is squarely in the path. All told, somewhere between 6 and 22 million Americans will spend Wednesday night inside some level of tornado risk. This is where the recent past becomes impossible to ignore. In March of 2025, the last time models agreed with this much confidence this far in advance, the SPC began tracking the threat 8 days out. By 4 days before the outbreak, model agreement allowed forecasters to upgrade their language from possible to probable. By 2 days out, the SPC issued only the third day too high risk in its entire history. The forecast text used the word violent, which the SPC almost never does. The outlook called for numerous strong tornadoes, some long track and potentially violent. The outbreak delivered exactly that. 118 confirmed tornadoes over 4 days. 3 reached EF4 strength with winds up to 190 miles per hour. A single tornado tracked 117 miles from Stone County, Arkansas to Butler County, Missouri, one of the longest tornado paths on record. The surface load dropped to roughly 975 millibars, among the strongest ever seen in the central United States. Total damage reached $11 billion, making it the most costly tornado outbreak in American history without adjusting for inflation. Coroner Jim Akers in Butler County, Missouri walked through what was left of entire neighborhoods. The floors were upside down. Rescuers were walking on walls. Dakota Henderson in Wayne County pulled survivors from rubble and found 5 bodies near his aunt's house. Michelle Ryan, the emergency management director in St. Louis County, had never seen this level of damage in her entire career. In Paragould, Arkansas, Misty Drope watched a tornado tear through her neighborhood for the second time in less than a year. There's a silence that happens before a strong storm hits. She knew exactly what it sounded like. $11 billion, 118 tornadoes. And the forecast that made it possible to save thousands of lives began with models agreeing 8 days before the first supercell fired. The SPC had never issued a day too high risk before 2006. They had only done it twice before March 2025. The language in that third release was direct. Numerous strong tornadoes, some long track, and potentially violent. When the SPC uses the word violent, they are talking about EF4 and EF5 strength. They almost never use it. The models gave them enough confidence to put it in writing. 2 months later, the models agreed again. May 18, 2025. This time, the target was western Oklahoma and south central Kansas. 133 tornadoes touched down in 4 days. 10 of them reached EF3 strength. A single cycling supercell in south central Kansas made 8 tornadoes in a row, 5 of them rated EF3, pushing the SPC to issue 2 rare storm briefings, noting most likely peak strength of 155 to 190 miles per hour. Grinnell, Kansas, population roughly 250, took a direct hit from an EF3 with 140-mile-per-hour winds. The tornado crossed Interstate 70, throwing semi-trucks into fields and snapping 15 power lines. It destroyed 28 homes, ripped the roof off the Catholic church while candles were still burning inside, and wiped out the Frontier Ag grain facility, causing $6 million in damage to that single building alone. Christy Rathgaber and Tristan Bixenman pulled people from the rubble, then opened a restaurant to feed the helpers who poured in from across western Kansas. That same night, a tornado emergency was issued for Greensburg, Kansas, only the second in that town's history. The tornado tracked northeast, eerily following the path of the deadly 2007 EF5. George Jennings Jr. sheltered with his wife and came out at the 10:36 p.m. all clear. The tornado had curved away at the last moment. Plevna, Kansas, was not as lucky in terms of where it sat, but was extremely lucky in every other way. An EF3 tornado 1 mile wide took a direct hit on the small town at 11:50 p.m. The tornado traveled straight through, and Reno County Fire Chief Travis Vogt could barely believe what he was seeing. A mile-wide tornado through a town with people in it, and not a single injury, not a single death. Most residents had sheltered in the town church. Across 5 counties, Niska Electric's general manager Teresa Miller and her crews faced over 400 downed power poles, 133 tornadoes across Oklahoma, Kansas, and Texas, 0 deaths. That number is hard to believe, and it is a direct result of forecasting that gave towns hours, and in some cases, days of lead time. The models told forecasters what was coming. The forecasters told the public, and the public listened. In Plevna, they sheltered in the church. In Greensburg, they went underground. Across 133 separate touchdowns spanning 4 days and 3 states, not a single person was killed. 1 month after that, the air had one more surprise for the 2025 season. On June 20th, a massive derecho and tornado outbreak swept through the upper Midwest. Near Enderlin, North Dakota, a wedge tornado touched down and was on the ground for 19 minutes. When the damage surveys were finished months later, it was upgraded to EF5, the first EF5 tornado in the United States since 2013, the longest gap between EF5 tornadoes since records began in 1950. Winds topped 210 miles per hour. An empty tanker car weighing roughly 72,000 pounds was thrown 475 feet through the air. Debris from destroyed homes was found 40 miles away in Moorhead, Minnesota. The upgrade to EF5 took months of damage surveys, and Melinda Behrens at NWS Grand Forks in charge of the review understood why it had been so long since the last one. In the past 12 years, several strong tornadoes had come close, but none had struck the right damage markers at the right strength to justify an EF5 rating. At Enderlin, the proof was clear. 3 people were killed: Michael Dalton Den, age 73, Catherine Ann Pfaff Den, 73, Marcario Machuca Lucio, 89. The 2025 tornado season produced 1,558 confirmed tornadoes in total, the most active season in 14 years. 68 people were killed. 6 tornadoes reached EF4 or higher. To put 1,558 in view, the long-term yearly average for the United States is roughly 1,200. The 2025 season beat that average by nearly 30%, and the deadliest month, May, produced more than 500 tornadoes on its own. That is the backdrop against which the current event is unfolding. Not a normal spring, not a quiet start. The Central Plains have been making historic outbreaks at a pace not seen since 2011. Okay, so here is where the picture gets truly messy. The forecasting system that produced those life-saving warnings during the 2025 season has been cut deeply. Between late 2024 and mid-2025, the National Weather Service lost roughly 550 to 600 workers through layoffs, early retirements, and firings. The NWS dropped below 4,000 workers for the first time in its history. 8 of 122 NWS offices fell below the staffing level needed for 24-hour, 7-day-a-week work. Weather balloon launches were stopped at 11 of 83 sites, and the SPC's own building in Norman, Oklahoma, was listed for possible lease ending. 5 former NWS directors, Louis Uccellini, Jack Hayes, D.L. Johnson, John Kelly Jr., and Joe Friday, took the rare step of issuing a joint open letter. The fact that all 5 agreed on anything was itself unusual. The message was blunt. The situation inside the NWS was reaching a breaking point. Staff were being ground down, working through the night and showing up again during the day because the next shift was short. The fallout showed up during the March 2026 tornado outbreak. No tornado watch was in effect in Michigan when an EF5 struck Union City. Governor Gretchen Whitmer called for a look into whether NWS funding cuts were a factor. The system is not broken yet. During the May 2025 Kentucky outbreak that killed 19 people in Somerset and London, the NWS Jackson office pulled together full staffing days in advance. Lead forecaster Christian Cassell and his team had seen the risk building well ahead of time and planned their coverage to match. Every EF5 and above tornado during that event got a warning. The average tornado warning lead time across the country sits at roughly 13 minutes, with warned events averaging closer to 18.5 minutes. 97% of EF3 plus tornadoes get warnings. Those numbers are the result of decades of spending and work. Doppler radar rollout, better models, the SPC's new conditional intensity graphics system that launched on March 3rd of this year. The system, built by SPC Deputy Director William Bunting and rolled out by lead warning forecaster Evan Bentley, replaces the old yes or no major severe hatching with 3 strength levels. Level 3 is saved for rare, historic outbreak level strength, violent tornadoes, intense derechos. The old tools simply did not show the difference between a bad day and a worst-case one. The new system does. That system is about to get one of its first real tests. The air over the Central Plains is doing something right now that it only does a handful of times each year. 4 pieces are coming together in a mix that exists nowhere else on Earth. Gulf moisture is streaming northward through the low-level jet, carrying surface dew points of 65 to 70 degrees deep into Oklahoma and Kansas. That moisture holds a huge store of hidden heat energy. When it rises and cools into water droplets, it releases that energy into updrafts that can punch through 40,000 feet of air in minutes. The dryline, that north to south boundary where humid Gulf air slams into hot, dry air from the southwest, is sharpening through central Oklahoma. Where the 2 air masses crash, the dry air wedges underneath the moist air and forces it upward. This lift is weaker than a cold front, which is actually what makes it more deadly. Weaker lift means fewer storms break through. Fewer storms means the ones that do form stay alone, separate, each one spinning on its own axis. Separate supercells are the most tornado-prone storm type on Earth. The polar jet stream is screaming overhead at 100+ knots, creating extreme wind shear through the full depth of the air. Surface winds from the south at 15 knots. Winds at 30,000 feet from the west, southwest at 100 knots or more. That difference in speed and direction is what tilts the updraft, splits the rain from the inflow, and allows a supercell to keep going for hours. And the cap, a layer of warm, dry air flowing off the high ground of the Rockies, is sitting like a lid over all of it, trapping energy through the morning and early afternoon. Every hour that lid holds, the stored energy underneath it grows. 3,000 joules per kilogram of CAPE is already extreme. If the cap holds until 4 or 5 p.m. and then breaks cleanly along the dryline, the first storms to punch through will tap into all of that stored energy at once. When that cap breaks this afternoon, and the models agree it will break, the built-up energy will release all at once. The strongest tornado outbreaks in history have featured this exact balance. Enough cap to build extreme energy, but not so much that it blocks storms entirely. The dryline gives the trigger. The jet stream gives the shear. The low-level jet gives the spin. And 3,000 joules per kilogram of CAPE gives the fuel. No other place on the planet makes this mix with this frequency. The Rocky Mountains create the cap. The Gulf of Mexico gives the moisture. The jet stream delivers the shear. And the flat, open ground of the Great Plains offers nothing to slow any of it down. Oklahoma alone averages roughly 60 tornadoes per year. Kansas averages around 90. Texas leads the country. Between those 3 states, the yearly tornado count easily tops 250. And the last 15 months have pushed those numbers well past normal. The 2026 season has barely begun. And the first event of the year already has models agreeing on numbers that put it in the same class as the events that defined last year. The March 2025 outbreak cost $11 billion. The May 2025 outbreak produced 133 tornadoes with 0 deaths. The June 2025 outbreak spawned the first EF5 in 12 years. Every one of those events began with the same signal: model agreement. The models are agreeing again right now. Wednesday's threat does not end Wednesday. The models show the system lifting northeast into the Chicago corridor on Thursday, then possibly reloading across Kansas and Oklahoma again on Friday, with even more extreme numbers. The Friday setup in particular has forecasters watching closely. Both the GFS and the Euro are showing CAPE values that could top the 3,000 joule mark by an even wider gap, with the dryline further east and the low-level jet even stronger. This is the pattern that defined the 2025 season. Not one-off events, but clusters. Multi-day outbreaks where the same weather engine reloads and fires again and again across the same ground. The March outbreak lasted 4 days. The May outbreak lasted 4 days. The June derecho spawned tornadoes across multiple states in a single night. 1,558 tornadoes in one season, and a huge share of them came in tight bursts where the air found a gear and stayed in it for days at a time. The April 1st through 3rd window has that same multi-day shape, a deepening trough that does not move out quickly, a moisture feed from the Gulf that does not shut off, and a dry line that reforms each afternoon along roughly the same north-south line through western Oklahoma. Every afternoon, the cap builds. Every evening, the cap breaks. Every night, the low-level jet ramps up. Forecasters at the SPC will be drawing new risk areas each morning through at least Friday. Weather YouTuber Ryan Hall, with over 1.6 million subscribers, has been tracking this system for days. His message to his viewers has been steady. Anything that weakens the ability to keep families safe is worth sounding the alarm over, and he is not going to stop. Right now, 22 million Americans are somewhere inside the threat area mapped by the Storm Prediction Center. Many of them will go to work, pick up their kids from school, and drive home on highways that cut through open prairie where the dry line will be sharpening overhead. Some of them live in mobile homes that offer almost no shelter from even a weak tornado. In Oklahoma alone, more than 300,000 people live in mobile housing. An EF1 tornado with winds of 90 miles per hour can roll a mobile home. An EF3 can erase one completely. And the numbers the models are showing right now are in line with EF3 and above. Some of these towns have no public storm shelters within miles. Jennifer Miller in Ada, Oklahoma, sheltered with her 12 and 16-year-old children during a tornado last year, with no public shelter anywhere near her apartment. Hunkering down in an inside room was the only option she had. Down the road, Devin Ryan put a mattress over himself and his younger sister in a hallway. The tornado passed close enough that another inch toward his house would have killed him. That tornado was an EF1. The numbers for tonight are much stronger. The cap is still holding as of this recording. Surface temps across western Oklahoma are climbing through the 80s. Dew points east of the dry line are pushing into the mid-60s. The pieces are all in place. The models agree. The SPC has drawn its risk areas. The NWS offices across Oklahoma and Kansas are fully staffed and watching. The question is not whether storms will fire. Every model, every forecaster, and every weather reading says they will. The question is whether the storms that form this evening stay separate long enough for the spinning updrafts to tighten, for the spinning columns to drop, and for the first tornado warnings to start lighting up phones across the Central Plains. That answer arrives in a few hours, and 22 million people are waiting for it.